So in this example, we have a class string L where we have a method by the name method, and at line 13 we're declaring a string ABC. So this string ABC is created and the reference is a string. So let's say this string is stored at address 100 and the string literal ABC is stored here. So at line 14 we print ABC equals to a string. It's a direct print statement, so that is printed. So in the output we have ABC equals to a string, and then there's a new line character, /n is a new line character, and then some space. So new line character and then some space we have. So in line 15 we have print whether ABC equals to a string. So is the string literal ABC and the address of the reference a string wherever it's pointing at in the memory, is the address of both of them same? ABC is a string literal. Now we already have a string literal at address 100. So compiler maps this string to address 100, and this is also referencing to the same point, right? Address 100. So this evaluates to true. Notice that this essentially means there's some space line here. So I'll just write it like this. And then in line 17 we have string new string equals to new string ABC. So another string is created ABC. This will be done at runtime. Since it's a new string that is being created, this will be done at runtime. Let's say this is stored at address 400 and this is now being pointed by new string. So the new string variable is referencing the string ABC string at address 104 in memory. So at line 18 now we check system out print line. So this is printed as it is, ABC equals to new string ABC, and there's this new line character and then some space. So it's like this, yes. And at line 19 we have system out print line ABC equals to new string. So is ABC equals to new string, this again is a string literal, so this is mapped to address 100 because that is where the string literal is stored. The new string points to the address 104. So is this the same? No. 100 and 104 both addresses are different, right? So this prints out to be false. Next we have at line 21 method 1 ABC. So ID is 1 right now. This is ABC string literal. This is also ABC string literal. So system out print line ID in method. So ID is 1 in method. This line is printed as it is. I'm just gonna write line 9. So this is printed after some space, line 9. And then at line 10 prints whether literal equals to a string. So this is the literal, that is ABC being passed, and this is the other a new string. So both are the same since both are string literals and they'll both point to the address 100. So this will print out to true. Then line 22 method 2. So 2 in method is printed with ID 2 because ID right now in this function call would be 2. So this is printed. Then again after some space line 9 is printed, and then we check whether the literal being passed is equal to the a new string being passed or not. Literal is ABC address 100. This is a new string created. So let's say at runtime this string is created at here. So this is the line 22 part in which this new string is created. This points here at 107 address. So is the address of this string literal 100 equal to this address? No, it's not, right? 100 is not equal to 107. So this also prints false. Then we have line 23 in which ID is 3 ABC AB plus C. This evaluates to ABC at compile time. So 3 in method is printed because we're printing the ID of the method. This is the first line in the method call. And then this again line 9 is printed. Line 9 is printed. And then it is compared whether these two strings being passed are the same or not. Yes, they are the same because they both are string literals with the same content. So this is printed out to be true. This will also print out to be true because this is 4 in method, line 9, and then this will also print out to be true. Why? Because this is a string literal will reference address 100. This is where it will point, and this also is essentially ABC string literal, which will also point to the same address. And when we compare them using double equals to operator, that will evaluate to true.